Right, okay, so right, in the previous video I was showing you on my phone my device now it's running. Now, this is what the oscilloscope is showing. I haven't changed the settings dramatically, maybe a little bit. I've changed the frequency of the touch, but I want to move it around a bit. But this is basically the LED output at the moment. I'm trying to get the camera, actually, I don't know, the camera's not too far off. So I'm just using a split screen. To show what's going on with the, where's the mini cam? Right, so the oscilloscope readings were on 200 microseconds, which is not even 1 millisecond actually. So there's 1000 microseconds in 1 millisecond. So we're kind of jumping actually between 200 and 400. I don't know what that is, maybe it's a blip. But it depends. Sometimes I do get slightly, because the pulse width is so small. It's a fraction really, and very small fractions are prone to variations in stability. So the smaller the fraction is, the more deviation we can see for the errors on the pulse width. So I've noticed this is a bit of a problem with temperature drift. I have had some issues with temperature drift when I start this up from scratch, from cold. And we're actually at we're at about 500 milliamps at the moment on the meter. On the meter I was showing in the previous video, which is one I recorded on the phone. So a little bit higher, but when I knock this down to the slower frequency, we can see the LED start to come on. I'll cover those up. You can see it on this camera because it's not very good. Anyway, at that current we are drawing more. The current consumption is going up slowly. I would say it's around about 600 milliamps at that speed. Probably higher, but I don't want to run it at that speed too long. It's more prone to errors, surgeries and problems. And I was discussing about problems where I can blow the MOSFETs. I have a switch on my circuit board for switching two capacitors in and out of circuit, so I can quickly go from low to high, so I can minimise the amount of frequency. This is the minimum amount of trimming pot unless I throw the switch. And as I go up in frequency, you'll see on the oscilloscope the actual frequency microseconds, second yellow writing on the right hand side down. It should actually go down to about 100 microseconds, but it's not. I don't know, I think this oscilloscope is a little bit limited. It's a Chinese knockoff, I think. I think it's it's a Handtech. It doesn't seem to give me very good readings below 200 microseconds, which is very odd. Because it puts up a question mark if the pulse width is too small. And this is why I hate digital things, because they're always in steps. They don't give you a linear readout. I can certainly go right down and we can see it go up to something like 400. There we go, it's up to 400 microseconds just down. So that is about 400 microseconds. Well, that's pretty good really. It's certainly better than what Robert Murray Smith was talking about when he was talking. He said that it was about a millisecond that you could flip Alnicos. Well, I've already been able to prove that we can flip them with a much smaller pulse width. Now let me take the magnetic return laminations off the top. Now if I get my gauge, you can see how well this is working. The Alnicos are flipping. I mean, there's no way, there's not a chance in a million years that a 200 microsecond pulse can move these magnets. The only reason these magnets are moving is because these Alnicos in these coils are being changed in polarization, in polarity. So as you can see, this thing's really going. Get this little light on a bit. Obviously this only seems to work with it, unless I get the right way around. We have to get it into resonance as well. And this thing wants to move around. So I'll get my other gauge. I made these myself. These are just magnets, opposing magnets, to give me an approximate idea on magnetic flux. So this is a different polarization. This one tends to have a lower frequency, a lower resonant frequency, so it doesn't respond as quickly unless I knock the frequency down. We get it in the right place. Flipping computer. My CPU is just getting hot. Right. Right. So getting the frequency. As you can see, that's at 1.8 milliseconds pulse. There's a bit of a delay before it cools down. Oh, I think I've discharged my supercapacitors. Oops. Yeah, they have to recharge again. Everything's sticking to these magnets. Right, so that's just a little additional video on the end of that. Oh yeah, I've got a lot of Manicam eats my CPU. One on live stream as well. Yeah, so without that annoying thing distracting me where I was, as I said, I've got these extensions to add on, these extension coils, and I was having some issues with the design on this. I wanted to make it simple to add an extra coil on the end without changing my design too much. I've actually made a completely new set, which I have not built yet. These are the new pieces, nice colours. So I've got my yellow magnet holders and lamination holders for the centre, which is the same as these. And I thought, why not have different colours, because it emphasises and shows the additional parts that are in there without, because this kind of blends all in, it's hard to see. But these little plugs, you pull them out, and my magnets go in these little holes, and it makes it easy for me to change my magnets out. I can just pull them out with another magnet or a piece of steel, because they stick to it, and then I swap the magnets over, and I can take my other plugs out and add other magnets in there if I need to, and then these little holes, access holes that go in between the lamination. The laminations have got a cutout like a notch where I can put iron in for tuning, like a tuning core. And then I've got the middle section which I can pull out as well. I have a core magnet that goes all the way down the centre. So it means I don't have to dismantle the whole thing to get to the magnets. So these are the new bits for the next build, which will also be compatible with this new extension. Because the way the extension works is this end piece, which is this piece. This is the end piece, right? And this is an end piece. This kind of is a really nice bit. It doesn't fall off. I have to slide it off, which is good. I can quite simply add these this extension section on. The way we do this is I put my end piece on there like this, which will have the steel laminations like on here in the end, and then this just clips onto the end of where these magnets on this one, the coils in here, and I'll just put that on like this, and it should be a nice snug fit. Look at that. It won't even fall off. It's such a perfect fit. And oh, my bobbins aren't straight even at the moment. Let's get these straight, don't we? It is a snug fit though. There we go, I've got them straight. And then this goes on, like I say, on here. Like that. And this will be pressing up, these bobbins will be pressing up against the bobbins that are inside here when they're installed. And so that's my extension secondary coils, which will be on the ends of this one or this one. Rather than carrying on though with this one, because this one's slightly improved because it's slightly further apart, very slightly further apart on the interior, but the actual exterior dimensions are the same. And this will just go up against that like that. And then there's the green coils, the secondary coils, which are these, where the LEDs are. There's some coils there. These will go between this yellow one and this yellow one. And then we have the other end there. So I'm not getting it all in camera, you see, but we have coils in between these two yellow pieces. Anyway, that all fits really well. I'm quite happy with the way it's come out. These bobbins keep falling around inside because there's nothing to push up against, because there's supposed to be some coils in here for them to rest on, and that's the only reason why they're flopping about inside. But you get the idea. Anyway, it came out well. I mean, because this thing holds itself together, more or less now. Which is, I've got the tolerances just right. And if I don't want to use the extension, I just take this end off and stick it back on here like that. Because it kind of slides on this one. It doesn't slide on that one. It's a push fit on there. So anyway, you get the idea where we are at the moment. So I wanted to make it in multicolours. There's nothing wrong with that one as such, but it's a bit bland. It's all one colour, and when I'm explaining things on the video, it's a lot easier to colour code everything. Colour coding is really a good way of explaining things to people. I mean, when I explain that the yellow parts are where the magnets and the laminations are held by, I don't have to point. And plus it looks better, doesn't it? And these are the other green set of coils, bobbins that will be going between the two orange sections, which I've made. And I've also made some holes in the ends there for the wires to go through, so when they're wound I've got somewhere for the wires to be threaded through without having to drill holes in the future, because it was annoying me to drilling holes all the time, so I decided to try and build it in, and so I did slots instead of holes, because holes have a tendency to get clogged up and slots seem to work better anyway. So anyway, my supercapacitors are charged back up. I'm at 250 milliamps right now. According to my analog meter across the room. So we can drop this frequency back down again. Oh, we're already through that frequency. Oh, that's interesting. Current consumption. Oh, of course, I know why it's dropped down in current. The temperature's dropped. This is a little bit thermally, circuit board is slightly thermally unstable. I've got a little bit of temperature drift on here. I can warm it up with my finger and the pulse width goes up. According to this, it says we're at 400 microseconds though. Yeah, I was just thinking about something. Have I knocked a wire somewhere? Cause, it seems to be dimmer than it was earlier. I don't know what that's about. Knocking things over here. Well, everything's cold, nothing's warm. Anyway, that's just a live update. I'll cut the stream short because I can waffle and it gets to 3 hours again.